All right, welcome everybody to Friday. And today we're going to do a short lecture first on linker errors because there are a lot of those on the project that was just due at noon. So let me, first of all, show you some notes. There's something in C++ called the one definition rule. You can only define a function once. If you have it twice, if you have two different mains and two different .cc files, and you try linking them together, it won't link because you've got two different mains. It doesn't know which one's the right one, and you'll get a linker error. If you call a function and that function never actually was written by you, like you can declare a function. Declaring a function is like a promise that future you will write this function. But if you never actually get around to writing it, then then you're going to get a linker error. So if you declare a function but you never define it, you're going to get a linker error. If you define a function twice, you're going to get a linker error. There's some tools for working with that, the static and the inline keywords. You got to play some games around that. But that's the basic rule in C++, is you've got to define everything that you declare, otherwise you're going to get a linker error. And this ties in with Makefiles. A lot of students are still weak on Makefiles. So I'm going to go over that a little bit as well. All right, so I guess I'm on my tablet right now. Linker errors suck, by the way. So they really do. They're not, like, I Googled like a linker error that I got, and like there was literally, nothing on it. Like it pulled up, like you can ask the people in the 12 o'clock class, it pulled up a video of a person talking about his mother dying. And I'm like, what does this have to do with C++? And the answer is nothing. So yeah, that happened. Okay. So let's get on the server and let's mess around a little bit and see if we can show you guys what some linker errors look like and what they mean. And cd linked list team 6. I don't know why there's two of them. Let's change the prompt. There we go. P3, P4, P1, P0. That's P3, I guess. P2. Yeah, it's the smallest one. Okay. So here we've got a makefile that's actually building 3 different targets. So this is something that a lot of students struggled with. So you have 3 different mains inside of this directory, which I don't necessarily think is always good practice. But it happens. It's just it's a decision you make. So we've got a C++ file called driver.cc that builds an executable called driver. We've got a C++ file called generator.cc, creates an executable called generator, and then everything else builds to a.out. A.out is the name of an executable when you don't give the name of an executable. So let's look at Makefile here and see how the student did this. So first of all, you can make a target called all. This is very common. And this will build all 3 of these targets. The name all doesn't mean anything. You can call it literally anything you want. In a Makefile, whatever the first target is, that's what gets built. And so if you have a.out as the first target, like this, then if we do a make clean and a make, it's not deleting driver. I should probably put driver down here as make clean. Make clean. Some students were doing make clean make over and over again, which defeats the purpose of a makefile. If you have to do that every time, probably your makefile is wrong. But when you're working on your makefile, it's like fairly common to like do a make clean and a make stuff. But like when you're actually building things for realsies, you shouldn't need to be constantly make cleaning and make. See if I take make again, look, you can tell like I don't have any work to do. This is the right way of doing things. Normally, you build your project by just typing make or MK for short, which clears the screen and then does a make. So by default, you saw that it built just a.out. And the reason why it does that is because I made a.out the first target. So it'll build a.out by default. But I can choose to build any target I want. So I can type make all. And then now it's going to build generator and it's going to build driver as well. And if I type make all again, nothing's to be done. Yep. So you can see you can make additional build targets like build all, make clean down here. Clean doesn't depend upon anything. It just runs this line of code. Every time you type make clean, it just deletes all the executables, deletes all the object files, deletes the core file, which we're not generating, I think, on the server now. And so I would recommend, like, if you're doing something like that, just making all the first target, and then it'll build all 3 of your executables. But it's a decision for you to make. So let's break something. So a lot of students were just like compiling things by hand, so they do something like this: g++ star.cc. Anyone want to guess what the problem is? Here, let me ls star.cc. Anyone want to guess what the problem is if you try building this by hand? If you try compiling all the .cc files together, what kind of linker error? Spoiler alert: we're going to get a linker error if we do this. What kind of linker error are we going to get if we combine all of these .cc files into one executable? Isn't sure what main to use? That's correct. So we try compiling it all, and we're going to get a multiple. Yeah, do you see what I mean by like linker errors being ugly? Let's see if we can read this. Multiple definition. Here it is. Multiple definitions of main. Multiple definitions of main. Okay. So we got a main here. Driver.cc line 11. That's what it's saying right there. Main.cc line 12 also has a main, and then probably a generator. There's probably a multiple definition there as well. Okay, so yeah, we got multiple mains. That's not good. So we got a multiple definition error. So we violated the ODR that way, right? This is a multiple definition error. Okay. So that's one of the most common mistakes you'll see. And that usually has to do with your Makefile combining different executables into one. Like generator is its own executable, driver is its own executable, main's its own executable. But like if you screw up your Makefile, and if you do something like, I don't know, let's just throw generator.o on there or something like that. Are we making generator.o or not? Let's just make it depend on generator.cc, and we'll just, I don't know, compile cc in there, something like that. Make clean, make. Then it is going to give you the multiple definition of main. Okay, because we have generator.cc, which has main. We've got main.cc, which has got main, and we can't make this work. So whenever you get that, that's usually a sign that your Makefile is hosed. Okay, and just look for whatever it is that you're getting a multiple definition of. If it says you're getting multiple definitions of main, that means you got 2 mains in 2 different files somewhere. Okay, so how do we find where they are? Well, it'll tell you for one thing. But if you want to find all of the places where main exists, you can just grep main in all the files. These have to be, let's do this. Okay, so grep is a search function. It's find in files. You can think of it as find in files. And so we are searching for the word main in all files in our directory. If we want to just search within .cc files, we can say grep main star.cc. And that will search through every .cc file for the word main. And in fact, we have 3 instances of main appearing in 3 different files. One of the files is called driver.cc, one is generator.cc, one is main.cc. There you go. There's your problem. Okay. And grep is a very, very useful tool for not just linker errors, but in general. If it's like, I don't know, we're calling get something, I don't know. Like you can find every instance of, like, let's say get next. I don't know why you would need this, but if you want to find every place where the word get next appears in any of your .cc files, there you go. That's all of them. Okay. And that's useful if you're like changing it, like you want to change it into the function from get underscore next snake case to camel case, where it's get next with a lowercase get and an uppercase n. Then you can grep for it and make sure you've caught all the changes. You're going through everything and changing them, and you miss one. In that case, I'd probably say use an IDE and refactor that way. Whatever. You can do a search and replace. you just do a grep and make sure that you caught all of the changes. It's a really useful tool. Okay. Now, what if we call a function that doesn't exist? What if we came into WGPT here, wgpt.cc, and we've got this get, oh yeah, front slash is search in bin. Okay, so if I'm going to search for get something, get underscore, I type front slash get underscore hit return, and then it's going to highlight every place on the screen where get underscore appears. And if I hit n, lowercase n, it goes to the next instance of the search. You can see how they're still highlighted on there. If I hit shift n, it searches backwards, 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 backwards. Okay. So I can, I don't know, let's say, let's undefine this function here. So now we've got a header file that is promising this wonderful function exists called getSize. And I forgot to write it. So which linker error are we going to get now when I try recompiling the code now? I might be calling the function. I might not, but I promised it would exist, you know, and it doesn't exist now. I've declared it, but I've not defined it. So what are we going to get? Undefined reference to type info. Yeah, we'll get to that one. That's a fun one. Anyone want to guess what kind of linker error we're going to get? If you've declared but never defined a function, you're going to get a linker error. Anyone remember what it is? Don't remember this one? All right, let's find out. Make, and here we go. We got a linker error. You can tell it's a linker error because it says user bin LD. LD is the linker. Okay. Collect to is so G++ actually runs a lot of steps, right? So if you just did like G++ main.cc, there's actually a lot of steps that take place all at once, right? So the what does G++ do, right? What does G++ do? It does the preprocessor. It does the compiler. It does the assembler. It does the linker. And then when you run, okay. So there's like 4 major steps. There's also the optimizer, and there's, you know, you can break these into sub steps as much as you want. But these are kind of like the big 4. These are kind of like the big 4 things here. So the preprocessor pulls, like when you do hashtag include, it pulls other files into your current file. That creates something called a translation unit. Like the static keyword creates variables and functions that are only visible within the current translation unit. So that, like, that's how, you know, that's the scope of static. Compiler converts your code from C++ into assembly, or an intermediate language, depending on, well, we're doing G++, but like Clang converts it from C++ into an intermediate language, and then it'll output assembly later. So then you get assembly code, and then the assembly code turns into object code. And so the preprocessor goes from like a main.cc to, I think it's like called main.i. I don't ever save my preprocessed files, but I think main.i, maybe, I don't know. It's been like 20 years. And then the compiler takes your main.i and turns it into a main.s. That's the assembly. And then the assembler takes it from assembly code and turns it into object code. And then the linker takes it from main.o and turns it into an executable called a.o. Okay. It's kind of a dark red. Let's make it a brighter red, maybe. There we go. Okay. So there's all these steps that take place. And if you type just G++ main.cc, it does all of them. All of them at once. That's why you're seeing linker errors when you think, oh, I'm compiling my code. Well, you are, but you're also doing more, right? So if you just type G++ main.cc, it does all of the steps. If you wanted to do just one of the steps, you can say like G++ -e main.cc, and that shows you the result of the preprocessed file. Okay. And so if we pipe this through word count by line, you can see that Camilla's main.cc is actually 97,000 lines of code, whereas the part that she sees as a human is 96 lines. So if we go into main.cc over here, you can see there is a grand whopping total of 96 lines of code here. But after the preprocessor runs, after all of these, includes are included, then it turns into something, 1,000 times the size, which is one of the reasons why you want to be careful when you are working with includes. Don't include things you don't need. Don't include things you don't need. This may be unused thing, by the way. If you don't have that there, it's gonna complain about unused variable. All right. So you can slap a colon, or not colon, a bracket. That's something called an attribute. And it's like a hint to the compiler, like, it's all right if we don't use it. Don't yell at me. I know. I know it's not unused. It's okay. And so the compiler will shush. So, or we could delete it, one or the other. I don't like warnings. I like my code 0 warnings, 0 errors. That's what I want to see when I'm doing coding. We got over here an implicit conversion change. Yeah. So she has here an integer, and the function itself, I think, takes an unsigned long. So there's like a conversion issue here. So we can fix this. Unsigned long. Cast it to that. That'll shut up that warning. Over here. Oh, we're okay. So list.contains. What's happening here? Why are we not outputting the result of this? Should probably output the result of this. Kind of no point calling contains if you're not going to do anything with it. I don't know. Maybe they're just benchmarking it or something. So, there we go. So, no warnings. I hope. No. Yep. No. Any other warnings? Yeah, that's what I like to see. All right, compile, and we're getting this linker error. So that collection thing there, that's like the high-level G++ thing that's making all the different pieces go. G++ actually calls different executables. LD is the linker. AS is the assembler. So there's different sub parts to G++ and GCC. There's like different executables that do those different steps between the compiler and the preprocessor. There's like different executables that it calls to do those different pieces. It's still not bright enough. I want this bright red. There we go. Okay. Yeah. So linker errors suck. So like LD returned 1 exit status. That means it did an exit 1. Remember how we talked about when you return an error code from main, 0 means everything's fine, 1 means there was an error, and you could feasibly return other errors if you wanted as well. So what we have here, the error we're getting is undefined reference. So that is the other error that we get. We get undefined reference error, which is tiny. Text only, thank you. And let's make you bright red as well. Okay. So these are the most common errors you're going to see in a linker, because the ODR says you get to declare something, you get to define something once. So if you do it 0 times, you get undefined reference. If you do it 2 times or more, you get multiple. So these are the most 2 common ones. But some of the errors you will get are mystifying. So let's make it worse. Okay. So let's come back into what was that wgpt.cc, and we will bring that back to life, but we are going to comment out the destructor. Okay. So with no destructor here, we've promised there's a destructor, but we have not written one now. So if we try compiling it now, we get this whopper of a linker error. Okay, warning, relocation against ZTV, WGPT in read-only section, .text. .text is your code segment. In function WGPT, it doesn't even have the right name of what the problem is. The problem is we are missing the destructor. We have promised C++ that a destructor for our class exists, and we didn't write it. It does not tell us that, though. It does not say, oh, hey, you forgot to write a destructor. That would be too easy. Instead, you get creating a DT textural in a pie. You know how many second semester computer science students are like, oh well, clearly the problem is I create a DT textual in a pi. This is just the vocabulary that I use on a daily basis. When I talk to my friends, when I'm talking about pies, man, I talk about DT textuals. That's just how I talk. Like everything on the screen here is terrible. Everything is bad. There is not a single thing on here that is helpful. So, undefined reference to vtable, undefined reference to type info, undefined reference to type info in splice, in merge. So you're going to look at merge, you're going to look at splice, you're going to look at the constructor. It is pointing fingers at 3 different places, and none of them is the right problem. The right problem is that we did not write the destructor that we promised we were going to write. So, yeah, I have no idea what a DT textual is. I don't know. Let's look up DT textual in a pi. I don't know. Let's see what we got. Last time it showed me some guy's mom dying or something, or talking about his mom dying. Let's see what we got here. DT textual in a pi. Pi, there we go. Harvest pi leaf, pi crust borders, C++ static with the Cherno. Great, awesome. More Pido, mutex lock and trilock. Race conditions. Undefined reference to win main. That's a linker error at least. Templates. Apocalyptus Noctis. What would Hitler have sounded like in English? That's probably the most relevant one. Yeah. Probably. Yeah. Build your first C++ GUI app. Probably not going to help us with this one. Quick collision. Yeah. Yeah, linker errors are terrible. Okay? And all you have to do is forget one of them, right? So you have to be very careful when you're doing inheritance. You make sure as you go through every single one of those pure virtual functions in the interface, everything that you set equals 0 in the header file that you include, that you inherit from, every single one of those things you need to overload. If you forget to overload one of them, bad things happen. Especially if you put it into the header file, right? Because in the header file, we say, look, right here, we say there's a destructor. We promised, we pinky swore that a destructor exists, and we forgot to write it. And if you do that, then yeah, you get error messages that are of no help to anyone whatsoever. Let's see what'll happen if we forget the constructor. Let's try that one. So the destructor is back. We're back, baby. We're so back. All right, here we go. No destructor now. Let's find out what kind of wonderful error messages we get here. Cool. So now the linker error. Again, this is a linker error. This is not a compiler error. The code compiles fine. In fact, if I say G++ -C is the compile flag. Remember, -E is preprocessor. -S, I don't know if I told you that one. That gives you the assembly code. If you want to see what the assembly code looks like, you can get it. See, it compiles fine. Main.s. Here's all the assembly code. You have this to look forward to in 2 semesters. Compiles fine. GCC-S gives you the assembly. GCC-C compiles the code and saves it as an object file. Okay, and you can do things like look at what's in the object file, and it tells you all the different functions, things like that. Cool. So let's do a make clean and a make. Build it over from scratch. You can see it's all compiling. It's not a compiler error. It is a linker error. User bin LD. And because we are using unique pointers instead of regular pointers, it actually makes the error messages worse. So here you can see the in function stood : detail : make unique WGPT : single object stood : make unique WGPT text.zst11 make unique i9 WGPT gene st 8 _ detail 9. That's all one word. Isn't that amazing? That's longer than like a word in German. Look at that. Okay, here we get the actual problem. Undefined reference to WGPT : WGPT. Okay, so that one's like you like there's like face melting. Like what? Like this like that's a word. That highlighted thing there is one word. Okay. Yeah, it's not helpful. It's not like imagine trying to teach just like a kindergartner, you know, like, all right, kids, we're learning to code, and then they get a linker error, you know, just like, good luck, you know, like, parse that, little Timmy, you know, like, have fun. You know, that's a big word there, and yeah, linker errors suck. Okay, but this is useful. So this part's helpful. Undefined reference to WGPT. We're missing the constructor. Better than missing a destructor. And again, linker return error status and so forth. Okay. So everything is fine. Everything is dandy. We can come back into wgpt.cc. There we go. Yeah. Okay. Let's get rid of front maybe, and then let's get rid of it in the header file as well. And now we are not going to get a linker error. We're going to get a compiler error. And the reason for this is because we took it out of the class. If you take it out of the class declaration, this function doesn't exist at all. Okay. And so this is now a compiler error because we didn't declare it. Linker errors come in when there's a mismatch between what you declare and what you define. If you declare something, you don't define it, linker error, undefined reference. If you declare something, you define it twice, that's a multiple definition error. Okay. But here we just didn't declare it at all, so it's not a linker error at all. This is a compiler error. Okay. So we can come over here. We're seeing invalid new expression of abstract class type. Abstract class type means that there is a equals 0 in the implementation file. It's inside of ll underscore interface.h. There's a bunch of functions that are all equal to 0, and we forgot to overload one of them. Okay, so because we forgot to overload one of them, it is still an abstract class. We cannot instantiate it. So come back into here. So you have to make sure, you have to be very careful that everything that is equals 0 in that base class we're inheriting from is properly overridden. And sometimes it can be very subtle. Like if you forget the const, for example, we're not overloading it now. This is a different function. If you have const and you don't have const, those are two different functions. And so you have to be very careful to copy the same number of parameters, the exact same spelling. You know what I mean? Like you have to be very careful that you are overloading exactly, you're overriding the function exactly. That's why the override keyword is so useful. It'll help tell you if you think you're overriding something, you're not. Okay. So now everything should we still left out. Yeah. Still left it out of the CC file. One last linker error to send us on our way. And there we go. Everything's fine. You'll also see linker errors if you forget to link in a library that you need. So let's come back in here and go to -l gtest. So gtest. Okay. So if we forget to link in a library that we need, and we try building the driver, this will also give us a linker error. So linker errors are also, they also take place when you need a library. A library is like a bunch of .o files put together. So there's a command called AR, and you can AR bob.a, star.o, and then let's see, what is it? AR. I don't remember the exact keywords for it. Yeah. I'd have to look up the command parameters, but basically, AR is a command that will merge together different .o files into a .a file. A .a file, for all intents and purposes, is a .o file, and then you link against it like that. Okay, and the -l command looks by default in your lib directory. Locate gtest is maybe more trivia that you guys need to know. Lib gtest is the name of the library, and there it is right there. Send user lib. there is a .a file called libgtest, and that's got all of your .o. It's like a .o file, basically. So if we nm this, you can see here's all the different functions that are defined in that .a file. And so if we try building our code without gtest linked in, we're calling functions that we haven't linked in, so we get an undefined reference error. Okay. So that's pretty common. Students forget to link libraries all the time. You also get a problem if you put the library first. So one of the this is one of the more pernicious problems. Because most of the time, the order of the command line parameters don't really matter. But whenever you have a library, it has to come after, like that. That's a little curveball that a lot of people don't know. Is your libraries have to come after everything else. Pretty much anything else, you can put the command line parameters in any order you want. That doesn't make a difference. Is it cursed? Yeah. I'm not going to sugarcoat it. Dealing with linker issues is like probably my least favorite part of C++. Possibly the lack of a good build system is more annoying, but that's kind of the same. Kind of saying the same thing. Linker's part of the build system. 50% linker issues, 50% linked list was your experience in the last homework night. Yes, girl. Yeah, he's just hanging out with us. He snuck in when I went to get my coffee. Yeah, bring him up to the camera. Show it off to people. Is he sleeping? Pick him up. All right. Yeah. Yeah, he's passing out. Okay. Yeah. Let sleeping cats lie. That's what my mom always used to tell me. 50% linker issues, 50% linked list problems is my experience. Yeah. So, especially with inheritance, you get some weird error messages, especially with a unique pointer. That helps obfuscate the problem. It's really one of the worst parts of C++ development is those error messages. But hopefully, after seeing the lecture today, in the future, you'll be able to understand them, fix them, and move on without getting stuck too much. Demystification, exactly. That's one of the reasons why you take a college class. Taking a college class, is you get sort of a systematic education and not only the language, but just when things go wrong, how to address them, seeing how somebody will dig into your Makefile and things like that. Because there were a lot of bad Makefiles over the last week. People were just trying different things because they were getting linker errors. They were just adding things and taking things out. Yeah, one more. Make clean. This was from last night. So they put into the CPP flags -C, and they put CPP flags -C here so that they didn't have to repeat themselves over and over again. But there's one little problem with putting never actually link into your code. The problem with never actually linking your code is that when it comes time to link, it doesn't do any linking. Where -C means go up to the link step, but stop before linking. It compiles your code, generates the assembly, does the preprocessor, compiler, assembler, generates the object file, and then it stops. So it never actually links your code. And so what it's telling you here is that the linker input file is unused because you're not linking anything. So by trying to save a couple, they didn't want to have the -Cs over and over again here, so they just put it up in the CPP flags. Yeah. So that was a fun bug. Another one, if you have address sanitizer on some of your files and not the others, then it won't link either. So that's why we put all of our CPP flags into a variable called CPP flags, and then you have uniformity across all of the build. Okay, so that is it. And next lecture will be stacks and queues.